After understanding the different types of the canonical form and the meaning of canonical form, now we are going to understand the derivation of controllable canonical form, right? Controllable canonical form. Okay. So for the controllable canonical form, first now let's say in general, the what is the what is the what is the form of the transfer function? How you write the strict proper transfer function? Anyone can tell me what is the form? How it can be written? What is the proper transfer function? What do you understand with the strictly proper transfer function?
Number of poles is greater than number of
Yes,
zeros.
degree of the denominator should be greater than number of the numerator. It means the number of poles should be greater than number of zeros. Very good. So it means GS equals to YS upon RS, and it should be the equal to the S power M plus BM minus 1 S to the power M minus 1 plus B1S plus B naught divided by S to the power n plus a n minus 1 s to the power n minus 1 plus dot 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 plus a1s plus a naught. We already have seen such type of the equation in the first or second video, yes or no, where you can say what should be the
And
criteria,
it's greater than
and
M. It's greater than M.
greater than or equal to m, but n not be less than in any form, right? So and all the coefficient are real, right? So this is the criteria. So अब हम क्या करने वाले हैं? Try to understand. Multiplying, we are going to multiply the sorry, wait a minute. Multiplying numerator and denominator by s to the power minus n. s to the power n से आप ऊपर नीचे numerator and denominator को just multiply कीजिए. What will be the result? Please tell me. Anyone can tell me? GS equals to s to the power minus n minus m. Can we write like this? Plus bm minus 1 s to the power, please tell me, minus of n minus m plus 1. Am I right? Plus up to the b1 में क्या लिखेंगे प्लीज? s to the power minus n minus 1. Yes or no? Plus b naught s to the power minus n. We have multiplied the s power n minus n in the numerator. Is it clear? Yes or no? Please tell me. Please
Yes, sir.
confirm. If you have any doubt, you may ask. Same, multiply s by s to the power minus n in the denominator also. What you will get?
1.
Yes, 1.
1. Yes.
A की power n.
Wait. 1. Plus, please tell me, a n minus 1.
N minus
क्या होगा यहाँ
S.
पर? s to the power
1.
minus 1 ना. s to the power minus 1 से मल्टीप्लाई किया तो minus 1 बचा ना. minus 1 plus a to the power n minus 2 s to the power minus 2 and so on. यहाँ क्या होगा? a to the a1 please s to the power minus
Minus
n minus 1
plus n minus
plus a naught s to the power minus n.
minus 1.
Am I right? So this is the form. So अगर आप ध्यान से देखें तो what is this, you know, ये क्या है पता है आपको? Suppose that this is equation number 1 और this is equation number 2. तो 1 plus GSH आपको आपने MSG पढ़ा होगा. MSG देखा है? MSG means not God of messenger. MSG means anyone? Mason gain formula. याद है? याद है Mason gain formula? Equation 2 is of the form MSG, Mason gain formula. Mason gain formula. What is MSG? Anyone tell me? GSH equals to summation of K PK
P.
pk
delta 1,
delta k
delta
upon
1,
delta k. याद है
delta.
आपको? What is delta?
Yes, sir.
So summation of k pk delta k divided by 1 minus वो लूप, सारा लूप आपको क्या करना,
Loops.
माइनस करना है, फीडबैक लूप. यस और नो? So
Yes,
this is
sir.
the LQ. Let's say what is the LQ? So I am just writing here for the more clarity. For the more clarity here, this is the sum of product of. Yes or no? Sum of product of. Sum of product of क्या है ये बताओ? What is PK? What is delta K? What is PK? PK is the forward gain.
Forward path gain.
Forward path gain. Yes,
Forward.
very good. Forward path gain. Sum of product of forward path gain and please tell me and क्या है ये डेल्टा के पाथ है ना?
Estimate path factor.
हाँ? Path factor.
Estimate path.
You can say the path factor. Yes or no? Path factor. Okay. 1 minus what is this delta summation of LQ? What is this? This is the sum of क्या करते हैं मेसन के फॉर्मूला में? Sum of feedback loop gain. Is it clear or not? If you not clear, then I will again try to describe in more descriptive way. Is it clear, or are you forgetted the Mason-Gun formula? Tell me first. Then I will proceed further. जल्दी बोलो. अगर
Yes, sir.
आता है तो
Clear.
ठीक है, नहीं तो फिर आगे बढ़ो. ठीक है, बोलो. सिग्नल फ्लो ग्राफ याद था?
Yes,
Yes,
sir.
sir.
Clear.
तो सिग्नल फ्लो ग्राफ में आपने पढ़ा होगा ये, है ना?
Yes, sir.
Yes, sir.
Yes, sir.
Is it clear? Okay. So if not clear, I'm just giving the one example. Let's say just take one example so that everyone can understand in better way. Let's say this is the x1 and g1. This is, let's say, x2. Let's say this is the g2. And this is the x3. Okay, then g3. Then this is the x4. और x4 से हमारा minus of h4. Let's say g4. Okay, and this is the x5. And this is the ys. And this one is the rs. And from x3 to x5 there's a forward gain, that's a g5. And x3 to x2, let's say we have minus h1, we have minus h2, and let's say we have minus s3. So now we have to find the transfer function. Okay, let's say we have to find the transfer function. What we will do? You have to adopt some techniques. So what is the forward path again? Please tell me. You have to find the ys upon rs. Yes or no? So summation of क्या है? pk del k. Yes or no? So summation of pk del k यानी p1 delta 1 plus p2 delta 2. यही है ना बेटा? अगर हम इसको डिस्क्राइब करें p1 delta 1 plus p2 delta 2 and so on, right? So p1 delta 1, what will the p1 delta 1? So पहले मैं forward gain को समझता हूँ. This is the forward path gain is this one, g1 g2 g3 g4 if I'm not wrong. So first path is this one, g1 g2 g3 g4 ये वाला. So हमने इसको लिखा g1 g2 z1 z2 z3 z4 एंड एनी इसके साथ जो आपका फॉरवर्ड पाथ है, ऐसा कोई लूप जो टच नहीं कर रहा हो. एवरी लूप इज टचिंग, आई थिंक. यस और नो?
Yes, sir.
एवरी
Yes,
लूप
sir.
इज टचिंग, देयरफॉर 1 minus 0. ठीक है?
Yes, sir.
Okay,
Yes,
this is
sir.
the factor. Okay, plus what about the second forward path?
G1, G2, G5.
G2, G5, Z1, Z2, Z5, and what about the 1 minus any loop which are not touching? H4.
Minus H4.
So minus minus plus become H4. Okay.
Yes, sir. Yes,
So
sir.
this is the overall, and no any other forward path again. So P1 plus P1 delta 1 plus P2 delta 2. Now it is time to write the delta. Okay, that is the 1 minus. So 1 minus, what is the sum of loop? Please tell me. अच्छा बताओ, तो पहला हो जाएगा G2H1, yes or
Sir,
no?
G2H1. Yes,
Minus
G2,
G2H1,
Sir,
ठीक
G2,
है जी?
G3, H2.
Yes,
G2, G3.
minus G2
G2, G3,
G3
G3,
H2,
H2.
ठीक है,
H2.
minus G1
G2,
G3 G4 G1 sorry G2
Sir,
G2
G2, G3,
G3
G4,
G4
H3.
H3, ठीक है, एंड सिंगल लूप कौन सा है? माइनस ऑफ H4, और एक लूप और है, कौन सा बेटा बताओ? G G2
Sir, G2,
G5
G5,
S3,
H3.
ठीक है,
H3.
तो G2
S2.
G5 S3, और ये आपका बन
H3.
गया total transfer function. So this is the transfer function. So you can write the transfer function like this one. So this is the MSG formula, right? Now, good. I hope it is clear now to everyone. Okay. So now let's say second example. GS is equals to, now I'm writing B3SQ plus B2S square plus B1S plus B0 divided by S power 4 plus A3SQ plus A2S square plus A1S plus A0. So हमने अभी पहले एग्जांपल में क्या किया था? We have multiplied s to the power minus n in numerator and denominator also. So what we will do here? Anyone can tell me? Maximum power is s to the power 4. So just multiply and divide by s power minus 4. Okay. So what do you write? B3 s to the power minus 1, B2 s to the power minus 2, B1 s to the power minus 3 plus B0 s to the power minus 4 divided by 1 plus A3 s to the power minus 1, A2 s to the power minus 2 plus A1 s to the power minus 3 plus A0 s to the power minus 4. ठीक है? Any problem? So what is the order? Order of the system is fourth order. If I'm not wrong, you can say that this is of the order fourth. ठीक है? So how many state variables are required to represent the system? Please tell me. What do you think? How many state variables are required? We need 4, क्योंकि 4 स्टेट वेरिएबल आपको चाहिए. यस और नो? क्योंकि मैक्सिमम ऑर्डर कितना है? 4. तो मिनिमम 4 स्टेट वेरिएबल्स आर रिक्वायर्ड, है ना, आर रिक्वायर्ड फॉर द रिप्रेजेंटेशन x1 x2 x3 x4. ठीक है? ओके. और साथ में जब आप इसका डायग्राम बनाओगे, व्हेन यू रिप्रेजेंट लाइक दिस, तो SFG सिग्नल फ्लो ग्राफ must have how many integrators are required? चूंकि 4 है तो 4 integrators we will see. Integrator s to the power minus 1, what is represent? It represents one integrator, 1 upon s. Yes or no?
Yes, sir.
So it is the
Yes, sir.
integrator. So s to the power minus 4 integrator will be required for the representation. Okay. Now I am coming to the controllable canonical form after understanding this type of the problem. So the controllable canonical form CCF. Okay. Let the, now we are going to represent any transfer function of order, let's say second order, for the third order system, let's say जैसा आपको इजी लगे, B2S square plus B1S plus B0 and SQ plus A2S square plus A1S plus A0. So this is the transfer function. Okay. This transfer function can be written as ys upon rs. Please see carefully. B2S square plus B1S plus B0. If anyone have doubt, let me confirm. Let me know what you have any difficulty to found. Just now I'm going to multiply by WS in numerator and WS by denominator. Any problem? Any problem? Please tell me.
No, sir.
No.
No, sir.
So if the block diagram, in the block diagram, suppose I want to represent the same system, so we can represent the system like this: RS 1 upon SQ plus A2S square plus A1S plus A2, sorry, A2 A naught, A naught, A naught, right? So this one is one system. यहाँ हमने एक WS ले लिया, and then B2S square plus B1S plus B naught, and here I have taken YS. Any problem? Same problem है कि नहीं? कोई problem इसमें किसी को? Can we represent like this?
No.
YS upon WS and WS upon RS. Same बात हो गया. So you can write here WS upon RS, WS upon RS is equals to 1 upon SQ plus A2S square plus A1S plus A naught. Or YS upon WS is equals to, please tell me, YS upon WS is equals to
1 by
B2S square plus B1S plus B naught. दोनों को मल्टीप्लाई कर दो, इस इक्वेशन को, you will get the same. Yes or no? So this system may be represented like SQ plus A2S square. Sorry, this is not square. Okay, this is the A2, right? Yes or no? A2S square plus A1S plus A naught into WS is equals to RS for this equation, right? So you can write here W triple dot, yes or no, plus A2 W double dot plus A1 W single dot plus A naught W equal to RT. Yes or no?
Yes.
RT. हमने इसको डेरिवेटिव से क्या किया? डिफरेंशियल फॉर्म में लिख दिया. Am I right? Any problem? No. If you don't have any problem, then you can write another equation like the state variable in the form of the state variable. Let choose the state variable. Let's say x1 equals to w. x1 is to w. तो क्या लिखेंगे? x2 is equals to, please tell me, x1 dot. What is x3? x3 is equals to x2 dot. What is x2 dot? x2 dot means x1 double dot. x1 double dot means x1 double dot means w double dot. ठीक है? So now we have represented x1 dot is equals to x2, x2 dot is equals to x3, and x3 dot is equals to, what is x3 dot? x3 dot means w double 3, w triple dot. Yes or no? W triple dot, it is the x3 dot. Am I right? Is equals to, क्या बन जाएगा बताओ बेटा? Please, minus of a naught w, minus of a1 w dot, minus of a2 w double dot plus rt from this equation. Is it right? So
Yes,
minus
sir.
of a naught, what is w? W is x1 minus a1. What is w dot? W dot is x2.
X,
What is w double
X3.
dot? That is x3 plus rt. So we have written x3 dot also. So this is question number 1, 2, 3. Okay. So you can now, you are able to represent your system like x1 dot, x2 dot, x3 dot is equals to, please tell me what will be the result?
0 1 0 0 0
0
1
1 0. Very
One,
good.
zero.
0
0
0
1
1. And what will be the value? Minus a
minus a
naught,
naught
Minus a
minus
dot,
a1,
minus
minus
a1,
a2.
minus a2.
Yes, very good.
x1
x1 x2
X1, X2,
x3.
X3.
And what will be
Yes.
the value of rt?
Yes.
0
0
0,
0
0,
1. Because
One.
x3
into
dot
RT.
is equals to only we have rt. Yes or no? So
Yes.
rt.
Yes,
Or
sir.
you can say simple r. Okay, now this is the representation for the input
ACM.
side है ना. अब आप आते हैं ys upon w. ys upon ws is equals to, you have written b2s square plus b1s plus b naught. So please tell me ys is equals to b2s square plus b1s plus b naught, और ये हो गया आपका ws. Okay, so you can write yt is equals to, please tell me, b2 w double dot. Yes or no? b1
Yes, sir.
W
W
dot
W
plus B naught
B not
W.
W.
Okay, so you can write simply B2 W dot means X2. Yes or no?
X2
X2. B1,
yes
sorry, B2 not W dot.
X
W double dot means X3. X3.
yes sir
This is the X2 and this one is the
X1
X1.
X1
Okay, so you can write simply YT is equals to P naught X1
B
plus
not B
B1 X2 plus B2 X3, or in the
yes
matrix form you can represent like
B not
YT
B1
is equals to, please tell me, B
B
naught
not
B1
B
B1
naught B1
B2, and
B1
this is
B2
X1
X1
X2
X2
X1
X3,
X1
right?
X2
So
X3
this is the form. So this is the canonical form. In the canonical form, you can see here, you know, the last row is the coefficient of all the inputs, right? All the input, A naught, A1, all the coefficients would be there here. समझ में आ रहा है? और यहाँ पे आउटपुट इस तरह से हो जाएगा. अब इसको हम ग्राफिकल SFG फॉर्म, नाउ कन्वर्ट टू द SFG signal flow graph. How we will draw the SFG? Okay. So how many integrator are required? How many integrator are required? Please tell me.
3.
3.
3
ठीक है?
3
This is the RS. Okay. This is the, let's say, YS. Okay. So YS से this is the X1. Then this is the X2. Then this is the X3. और X3 के बाद क्या चाहिए आपको? Please tell me. X3 dot. Yes or no? X3 dot.
yes
ठीक है?
yes
Now,
yes
as per the equation, you can write the equation. Simple. So what is the X1 dot? As this is the X1 dot.
X1 dot
X1 dot is equals to X2.
X2
ठीक है? X3
X2
is equals to X2 dot.
X2 dot
Right?
X2
X3 dot is equals to this. So now X3 dot is equals to, you will write minus of A naught X1. ठीक है? Minus of A naught X1. So this will be the minus of A naught X1. Minus of A naught X1. ठीक है जी? Yes or no? Then आपने लिखा है ऊपर में, आपने ये इक्वेशन लिखा हुआ है, देखिए, माइनस ऑफ ए नॉट एक्स वन, देन माइनस ऑफ A1 X2, माइनस A1 X2. सो माइनस ऑफ A1 यहाँ से X2 से कहाँ जाएगा जी? यहाँ पर कितना? माइनस ऑफ A1. देन इट विल बी द, प्लीज टेल मी, इट विल बी द A minus of A2.
A2
You can see the equation. You can see the equation. This equation is written here.
yes
The equation is written here, minus of A2 X3, right? And last is plus RT is also there. Plus RT is also there. So what about the RT? RT means this is the
input
हो गया. X3 पे आ गया सारा कुछ, X3 डॉट पे, X3 डॉट पे इतना आ गया, यहाँ से आ गया, यहाँ से आ गया, प्लस. Is it clear? Now what about the YT? YT is equals to YT. This is the YT. YT is equals to B naught X1. So this is the B naught X1 plus B1 X2.
B1
Sorry,
B1
यहाँ पे sorry, B1, ठीक है, B1 X2 and then B2 X3. B2 क्या हो जाएगा? X3.
B2
Am I right? यहाँ सब भाई.
yes sir
So you can represent the system like this. So just for the practice purpose, you have, I am giving one example. Try to solve this example. Let's say the transfer function.
ఎలకం చూడు లాడు వస్తున్నాయి
Hello,
కదా
please
సౌండ్లు
mute
ఎక్కడి నుంచి
the mic.
చిన్న చిన్నవి బాగా చూడండి సౌండ్ వస్తే
Please
అవి
mute the
తిరిగిపోవడం
mic.
కాదు గుండె వేసుకొని
PD Pawan. The transfer function of the system is PD Pawan. Please mute the mic. Ys upon Rs is equals to 2s plus 5 divided by s square plus 7s plus 10. This is the problem. So you have to represent the system in the form of the CCF. You have to find the CCF. So जल्दी जल्दी से हम लोग quickly इसको solve करते हैं. Ys upon Rs You just multiply the same with the help of WS and WS. Okay. So anyone can tell me WS. This is the WS upon RS, right? WS upon RS become. Please tell me what upon S square plus 7s plus 10, and ys upon ws is your 2s plus 5.
2s plus 5.
2s 2s plus 5, right? So it becomes s square plus 7s plus 10 into ws is equals to rs. This will give the double dot plus 7 w dot plus 10 w plus 10 w है ना
Yes, sir.
equal to
So RT.
rt, right?
RT.
So defining or choose w is equals to x1 and x1 dot is equals to x2, that is the w dot, and and क्या हो जाएगा बताओ, and x2 dot is equals to
X2 dot equals to
w
X3.
double dot,
Oh,
and w
W
double
double.
dot is equals to, please tell me, minus then w minus of 7 w dot plus rt,
Plus
or
RT.
you can say minus 10 x1 minus 7 x2 plus r. Okay, so you can represent the input, the first state equation. First state equation is equals to, yes, okay, please tell me x1 dot x2 dot
X2 dot
is
is
equals
equal
to
0 1 minus 10 minus 7.
0
0
1.
1
Yes, please. 0 1
Minus 10 minus
minus 10
7.
minus 7.
minus 10 minus 7
7.
x1 x2, and what will
X1
the
X2.
for the
0
input
1.
side, 0 1
Plus 0
r.
1
Okay,
RT.
and last equation for the y side equals to 2s
1
plus 5 ws, and for this purpose yt can be written as, please tell me, 2 w
2
dot plus 5
No.
w,
plus 5 W.
and it is 5 x1 plus 2 x2, right? So y
Yes.
can be written as 5 2
5 to
x1
X1
x2.
X2.
So this is the diagram. Okay, you can also draw the diagram, है ना, like that, for from the above SFG, right? So this is all about the CCF, control canonical form. In the next video we will try to understand the observable canonical form.